Hello everyone and welcome to our first session, Engineering Calculus. So, good day to all. This time we are going to have the introduction wherein we have these learning objectives. Number one, for you to recognize the significance of engineering calculus to your course and then solve problems on functional notations. So let me start with the definition of calculus. So calculus is that branch of mathematics that deals with growth, motion, maxima, and minima. So meaning, the keyword here is a certain change. So in essence of time, there are always changes, wherein variables are used to change from growth, motion, maxima, and minima. So to illustrate that further, let us consider this ball. Two balls actually. Balls are in terms of the spherical shape. So when we have a spherical shape, of course, it is implied that this has a corresponding volume. These two balls actually have different volume and it has also different radius. A certain change in volume can be derived by your calculus. Say we have here two spheres, and of course there will be a difference in the volume. So by using differentials, we can facilitate the values of that differential volume. Say for example, we have certain radius. The original radius, for example, is we have say 2 units, and there will be a change on that to final radius equivalent to 2.05. So we know that the formula for sphere is actually given by this. V is equal to 4/3 pi r cubed. So if we are going to apply the procedures on differentials, it will generate differential values here like dv. So v will become differential v, or the difference in the volume. So the constants are maintained, okay, and then r cubed, we derive that, becomes 3r squared dr. So in your equation, you can see now we found the equations involving differentials like differential volume and differential radius. So all we have to do is to substitute the change in radius so that we can derive the change in the volume. So with this, dv is equal to 4/3 pi times 3. R squared is 2 squared times the change in radius, which is obviously 0.05. Okay, so with that we will have the value of dv equivalent to 2.51 cubic units. So this is the procedure on differentials. So it can deal with the change in volume, which is under growth. Okay. So with respect to the change in distance, of course, that implies motion, because for vehicle in motion traveling at a certain distance, there will be a change in distance with respect to time, which refers to speed, right? Hence, we can say that the differential in the distance, say we'll just represent that by S with respect to difference in time. This shall equate to speed or velocity. Okay, so meaning the differential of distance with respect to time, there will be a corresponding speed, or what we call velocity. So in later chapters, we will know that that is actually time rates. Okay, so this is what we call time rates, or d over dt. So later on we will go over with the details of that. Likewise, if such change in distance is not constant, there is a change in speed with respect to time that is often called as acceleration. So meaning, if we have d over dt, or time rates with respect to the speed, this is what we call acceleration. And as I've written a while ago, that this is supposed to be velocity, and this shall be dv over dt is equal to acceleration. So if we wanted to express this in terms of distance, the first time rates is actually ds over dt. This is our velocity. Okay, so this velocity changes, velocity change, so meaning again we are going to derive this with respect to the time. Therefore, this d over dt of ds all over dt is actually the acceleration. So, twice nating dinerive yung distance with respect to time. Okay? So, that will be its acceleration. So, moving on, don't you know that volumes are derived by calculus? Okay? What do you know about the formulas? So, yung formula ba, nandyan na lang yan dati? Of course not. It came from a derivation of the formula. So, formulas of volumes were derived through calculus by Pappus theorem. How is this? If we notice, if we're going to rotate a certain triangle, okay, on its vertical axis, it will form a cone, okay? And then if we have a rectangle rotated at the vertical axis on one side, it will form a cylinder, okay? And if we have here a rotation of a plate horizontally along the axis, it will form actually a sphere, okay, a spherical. Or this is a half circle rotated at its radius, okay? So to give you an idea, the Pappus theorem is just this one. Volume is equal to 2 pi radius times the surface area times two pi r times a, sorry. So r here refers to distance of the centroid from the axis of rotation. Okay, so if we have here the triangle, so we know that the centroid of this triangle from the height is actually 1/3 of the base, which is, say this is, say the base here is B. Okay, so 1/3 of B locates the centroid of this triangle up to the height of the triangle. So therefore that equates the distance of the centroid from the axis of rotation, so that if we're going to substitute that one, 2 pi, this is 1/3 of the base times the surface area. What is the surface area of a triangle? So we have 1/2 base times height. So that if we are going to simplify this one, 2 here is just cancelled. So what is left? We have 1/3 pi times b squared h, which is actually the volume of the cone. So the volume of the cone is given by that formula, 1/3 pi r squared times height. Base here would equate now to radius, because as we rotate this one, it will form a circular base for a cone. So that is why B here originally came from the base of a triangle that was rotated along the vertical axis. So this is the Pappus theorem, simply using the area and the distance from the centroid. So likewise for cylindrical one, we can derive also the formula. So what do you know about optimization? So when we say optimization, we tend to maximize or minimize a certain variable for us to achieve our intention. Like if we have a triangle, the question is, what will be the largest circle that can be inscribed out of this triangle? And optimization could also be applied to business, construction, and experiments. So about optimization in business, the calculus maxima minima increase beneficial values like profit, efficiency, and output. In construction, calculus maxima minima minimize materials given a certain parameters like area and perimeter. So in this case, if we intend to enclose our lot by a perimeter fence at a certain area, we can minimize the material of the perimeter fence. So this similarly, if we need to construct a boiler out of a sheet material, by maxima minima, it can minimize construction materials given certain parameters like area and perimeter. So this time, our intention is to maximize the area given the sheet material. So in experiments, the same calculus maxima minima, a chemist could determine where an electron is mostly likely to be found in any given orbital. Calculus maxima minima also, in experiments, makes a meteorologist create a model that predicts temperature variance with respect to time. So, meaning, those few examples just manifest that calculus is everywhere and continuously advances technology. So marami pang examples, or there are lots of examples that involve calculus in advancing technology. So moving on to the first topic, we have the functional notation. René Descartes used a power of x, of a variable x, until Peter Dirichlet conceived a function of y, dependent y function of x, variable to be determined in definite manner by values of x. So from the concept of René Descartes, x pa lang, karon na ng function ng y to represent also the dependent and independent variable. So the dependent variable normally is expressed in y, and x is the independent variable. So we know that variables are changing value, which is commonly denoted as x, y, or z, wherein constants are normally fixed value in numerical form. There are two different functions. We have the single-valued functions and the multi-valued functions. Single-valued functions are normally the first-degree equations, or what we call the linear functions. So the linear functions just have an equation without any exponents. Say for example, y is equal to 3x plus 8. So this is a linear function, or it could be z is equal to 4x plus 18. So these are linear functions, meaning the variables contains no exponent, while in multi-valued functions, we have the quadratic formula. For example, we have y squared, or a quadratic equation, y squared is equal to bx plus c, or an equation containing higher degree variable, say x cubed is equal to 4x squared plus 10, okay? And even fourth up to higher degree equation. Okay, so these are some examples. So for dependent and independent variable, if we have a formula for an area, say area of a circle, this is pi r squared. A here is what we call the independent variable, sorry, should be dependent variable because it is dependent on the radius. So, ibig sabihin lang yan, the radius is a changing value, meaning as the radius changes, A changes also. Certain change in R would mean change in the area. So, meaning the area is dependent to the radius. So, this is the dependent variable. Okay. And this is constant. Wherein this is the independent variable. Okay. So further we have functional notation. The symbol fx is used to express function of x. Similarly, function of y for the function of y, or fy for the function of y. Hence we have fx, a function of x. Gx would be another function of x. And that one will be another function of x. So in a moment, we're going to have examples. Say, let us consider this example. The function of x is equal to x cubed minus 4x plus 5. If we need to express this in another function or variable, say the same function with this different variable, then this will be equal to a cubed minus 4a plus 5. And for the same function, wherein it's function of 0 for this equation, just have to replace that by 0. So therefore, this equates to 5. So function of 0 is equal to 5. And if we have another function C, function of sine theta, then this must equate to sine cube theta minus 4 sine of theta plus 5. So that is about the functional notation. So let us have more examples. See, this is the first example. So let us have another one. Number 2. See, given function of x equal to x cubed minus, or x squared minus 5x plus 10. Say we're gonna find f0, f1, function of -2, function of 3. So all we have to do is to substitute each of these functions. So starting with function of 0, just have to perform substitution. So this is 0 squared minus 5 times 0 plus 10. Therefore, function of 0 shall equate to 10. And then for function of 1, you just have to substitute that to the equation. So the value will be equal to positive 2. And then for function of -2, we have -2 cubed minus 4 times -2, that is squared, minus 5 times 2 plus 10. We have f -2 will be equal to -4. And lastly, for function of 3, we have 3 cubed minus 4 times 3 squared minus 5 times 3 plus 10. Hence, function of 3 will be equal to -14. Okay, so let us have more examples. Okay, so let us consider this example. So if function of theta is equal to sine 2 theta, let us find function of 0, function of pi all over 2, function of pi all over 3, and then function of 180 plus theta. So for the first function, so let us have f0, this is equal to sine 2 times 0. So in short, that is sine 0, which now equates to 0. Okay, so for the next function, say function pi all over 2, so we really need to express this pi into an angle because pi is in terms of radians. So remember that in a quadrant, say this is the quadrant, a half revolution is equal to 180. Okay. So the half revolution is equal to 180 degrees, and it completes a revolution of 360 degrees. We all know that. And in terms of radians, a half revolution is actually pi, and the complete revolution would mean 2 pi. So therefore, if we are going to convert this one, the conversion factor therefore is that in a pi there is 180 degrees. So this will be the conversion factor. So for pi over 2, let us just multiply this by your conversion factor, wherein pi is equal to 180 degrees. Hence, that is 180 over 2. That is equal to 90 degrees. Okay. So, therefore, pi all over 2 simply is equal to 90 degrees. So, if we're going to calculate that, we have sine 2 times 90, or that is equal to sine 180 degrees. That will be equal to 0. That equates to 0. Next, how about the function pi all over 3? Now, pi all over 3, just the same, will be converted into equivalent angle. So, we're going to multiply here. The conversion factor, pi radians is equal to 180 degrees. So, 180 degrees all over 3 is equivalent to 60 degrees. Hence, pi over 3 is simply 60 degrees. So, we have sine 2 times 60 degrees, or that is equal to sine of 120 degrees, which equates to 0.866. 0.866. And then finally, we have the function f phi plus theta. Hence, phi plus theta is function pi 180 plus theta. So this will now be a different scenario, because if you're going to substitute this one to the function, we need to use identities. So simply, this is sine 2 times 180 plus theta. Okay, so be careful that it does not mean that we just do it this way, ano? Gawin nyo to. Sine 2 times 180, and then plus sine 2 theta. So this is actually unacceptable. Okay? So what we do is to use trigonometric identities. So what would be the applicable trigonometric identity here? Say we have the double angle identity. The double angle identity. So what is that double angle identity all about? So it is that sine 2 theta, which will just be equal to 2 sine theta cosine theta. Okay, so if we are going to apply this to this equation, it will become 2 2 sine theta cosine theta is equal to another identity to simplify this. So 2 sine theta cosine theta, kopyahin mo lang yan. So retain yung 2, kopyahin mo lang yung angle nya. So we have here 2 sine, the angle is 180 plus theta. So yun din ang angle ng cosine. So cosine 180 plus theta. Okay. So again, do not distribute that one. It's fairly wrong. So perhaps you can separate this by a bracket here. Okay. So from this, we can now use some identity. Say we have some identity. So for the sum identity, we have, if we have sine of the sum of a certain angle, say x plus y, this will just be equal to sine x cosine y plus sine y cosine of x. Cosine of x. And then from that, we can apply this one to this equation. So again, meron dati na yung 2 dyan. Okay. So i-apply lang natin yan dito. So the first term goes this way. Sine, by the way, this is the x. And this would be the corresponding y. Ano? So yung sine of x, sine of 180 yun. And then this is cosine of theta plus sine of theta, and this is cosine of 180 degrees. So this is for this function only. Okay, so meron pa yang cosine identity dyan. So cosine identity, some identity for cosine naman, say some identity for cosine, say cosine x plus y. We have cosine x cosine y minus sine x sine y. So if we're going to apply that to this one, second term, no? So we set this one as x and this one is y. We have cosine of 180 cosine of y, which is theta here, minus sine of x, sine of 180, and this is sine of theta. Okay, so we will now simplify this by certain values of sine 180 and cosine 180. So sine 180 will be equal to 0, no? So 0 yan. So meaning all of these terms will be equal to 0. So nandito yung 2. So the first term will become 0 because it's being multiplied by sine 180, which is equal to 0. So how about cosine of 180? Cosine of 180 is actually negative 1. So negative 1 yan. So retain natin yung sine theta dyan. Sine theta. This is negative 1. Cosine 180. Okay. So yung cosine 180 is negative 1 pa rin. Negative 1 times cosine of theta. Okay. It's getting slower. Say this is cosine theta minus all of these terms will be equal to 0 because sine of 180 is 0. No? So this is 0. Okay. So what is left? Negative 1. We have 2. Negative sine of theta times negative cosine theta. So just the same, it will yield to positive kasi negative times negative is positive. So finally, let us have 2 sine theta cosine theta. So ano naman to? If you notice, this is 2 sine theta cosine theta. This is sine 2 theta. So balik siya doon. This is equal to sine 2 theta. So if that is the case, we can say that function of pi plus theta is simply equal to sine sine 2 theta. So yung nakuha natin dito is actually sine 2 theta. Interestingly, class, itong sine 2 theta na yan is actually function of theta dito. Okay? So therefore, function of, so what's happening here? Therefore, function of pi plus theta is equal to function of theta. Okay? So that's for problem number 3. So let us have another one. See, let us first delete. Okay, moving on to this fourth problem. If we have the function of x is equal to x raised to 4 plus x squared minus 4, find function of t minus 1. So in here, we have higher degree or multi-valued functions. So meaning we're gonna expand this expression. Okay? Because this would yield to, say, function of x raised to 4 is actually t minus 1 raised to 4 plus t minus 1 is squared, and that is 4. So we now expand t minus 1. Okay, so t minus 1 times t minus 1 is actually t minus 1 raised to 2. So we have here t squared minus t. This is minus t. This is positive 1. Okay, so we'll yield it to t squared plus 1, or minus 2t, I should say. Dapat minus 2t yung minus 2t plus 1. So this is the value of t minus 1 squared. So we further multiply that by t minus 1, it will become t minus 1 cubed. So we have t cubed minus 2t squared plus t, right? And then minus t squared plus 2t minus 1. Okay, so we have t cubed minus 3t squared plus 3t minus 1. Okay, t cubed minus 3t squared plus 3t minus 1. So again, we multiply this by t minus 1. We have t raised to 4 minus 3t cubed plus 3t squared minus t. Okay, so for the negative 1, negative t cubed yun, and then that would yield to positive 3t squared, and then this is negative 3t, then this is plus 1. Okay, so we have t raised to 4 that combines, becomes negative 4 t cubed, that also combines to 6 t squared, and that will combine as well. We have, 4t dapat. For t plus 1. Okay, so this is the fourth multiplication of t minus 1. So t4 minus 4t cubed plus 6t squared minus 4t plus 1. So all we need is to substitute that value here. So it becomes t4 minus 4t cubed plus 6t squared minus 4t plus 1. Alright? And then we add this. What is that value? T minus 1 squared. T minus 1 squared is actually this. So we have plus t squared minus 2t plus 1. Okay, so we combine like terms, similar terms here. T4, wala siyang kapares, so it will remain to be T4. How about T cubed? T cubed has no pair, so we retain 4t cubed. Okay, and then t squared, we have another t squared here, so both are positive. It will just combine to 7t squared. So again, t has a pair of negative 2t. So negative 4 and negative 2 will just combine to negative 6t. And then 1 plus 1 is equal to 2. Hence, this equates to the function of t minus 1. So this is the answer. Okay? So may we have another problem? Okay, so let us solve problem number 5. So problem number 5, if fx is equal to x cubed minus 3x plus 1, find f theta plus 1. Okay, so this is a similar concept. You just substitute this function, say theta plus 1, this is cube minus 3 times theta plus 1 plus 1. Okay, so again we're going to perform squared functions. So this is theta squared plus 2 theta plus 1. And then again, we multiply that by theta plus 1. So this is theta cubed plus 2 theta squared plus theta, and then plus theta squared plus 2 theta plus 1. So what is combined here? So theta cubed plus 3 theta squared to, and then plus 3 theta plus 1. Alright, so substitute. We have theta cubed plus 3 theta squared plus 3 theta plus 1. Okay, so ito na yun. This 1. Then minus 3 times theta plus 1 plus 1. So simplify. You just copy that. 3 theta squared plus 3 theta plus 1 minus 3 theta minus 3 plus 1. So we combine terms here. So anyway, yung theta cube wala namang pare. So it will remain to be that value. So for theta cube yan. Same true with 3 theta squared. So 3 theta and 3 theta is cancelled. Cancel. So negative 1. So 1 plus 1, 2. 3, negative 3 plus 2 is negative 1. So finally, this shall be the function. So function of theta plus 1 is equal to theta cubed plus 3 theta squared minus 1. Okay, for your sheet work for today, I will leave you these problems 1 to 6, which will also be posted on your Google Classroom. So uploading shall be done in your Google Classroom of your answers. So this shall comprise of 5 points each. So 5 points each. Your sheet work for today will be equal to 30 points. So deadline of submission will be specified in your Google Classroom. So thank you for listening and have a good day, class.